All right, example 5. How many ways can you arrange the letters in the word THESE, or these? So we basically just want to reorder them. Now they do have to be unique ways, so that's something that's not said here. They do have to be unique. But basically, if I think of back, so we got 5 different letters, or sorry, positions, and we actually have 4 different letters. Now that is an issue, but let's just say it wasn't an issue and we were okay just rearranging them. So we go 5 times 4 times 3 times 2 times 1. So we use fundamental counting principle. You also know at this point that that is 5 factorial. Or you might think, hey, I can just go 5, pick 5, because I have 5 options and I have 5 of them I'm going to choose. And so that would be equal to 5 factorial over 5 minus 5. And previously we said 0 factorial was 1. So we still end up with 5 factorial. So no matter how we do this, we end up with an answer of 60. Or sorry, not 60, 120. The problem is that's not quite correct here because we have 2 letters that are the same. Meaning if I write THSEE and then I write THSEE again, but the E's are switched, are those different words? No, it's the same thing. So we have to deal with the fact that if the E's switch positions, that we actually get the same word. And that can occur in many different places. So it could be like EHSTE, and we could write the same, like we could have these E's in different positions as well. So how do we get rid of all of those duplicates then? Well, this causes there to be double the possibilities that there really is. So what we're going to do then is we're going to take our 5 factorial and we're going to divide by 2 factorial because there is 2 factorial ways that these could be positioned. Now that is just equal to 2, so really there's just 2 different extra ways that these cost per line of combinations. So we go 5 factorial divided by 2 factorial. So really it's going to end up being 5 times 4 times 3, which is 60. Let's look at one more word. So this time we have reference. Again, rearrange the letters. So let's just count how many positions there are. There's 3, 4, 5, 6, 7, 8, 9. So I'm going to use our permutation. I don't want to have to write out all the letters again. So I've got 9, pick 9. So I end up with some kind of factorials. So that should be 9 factorial over 9 minus 9, which is just 0 factorial or 1. Now that isn't the end of this though, because we do have some repeating letters here. So we have an E once, twice, 3 times, 4 times, which means there's 4 different, like 4 possibilities of how these could go, or sorry, more than 4 factorial ways that these could positions of these E's. So just like before where we divided by the 2 different paths this could create, now we're actually going to divide by the 4 factorial paths this could create. Now that's not the only repeating word though. There is also an R that repeats here as well. So there's 1 here, 2, I think that's it. So we're going to divide by 2 factorial to get rid of those repetitions as well. And so this is going to change our answer considerably. So our numerator is going to become 9 times 8 times 7 times 6 times 5. Once the computer starts jumping around on me here. 5 and then times 4 factorial. And so then on the denominator we have 0 factorial, 4 factorial, and 2 factorial. The 4 factorials will cancel out, and 0 factorial is just 1, and 2 factorial is 2. So we're left with 9 times 8 times 7 times 6 times 5. And when we put that in the calculator, you get 7,560.